Okay, today is called complex numbers and complex properties. So, what is a complex number? Is it a complicated number? No. It's a number that is in the complex number system. Later this hour, you're going to understand why that is a problem. See that square root in the denominator? That's not legal. I know we talked about this before, back when it was simpler. It was like 2 over square root of 3. Like, we just let those go. But in the complex number system, it's a bigger deal. We can't let you leave answers that have square roots in the denominator. Or other things like I, because you know what I really is? It's a square root. It's the square root of a -1. But anyway, you're going to learn how you can fix these things. So, first up, the polar trig equations lab. We will eventually do just a shortened lab when it comes to the polar lab. What you still have out there is the daylight lab. I haven't forgotten about it. We are going to grade that still. But today's shortened day, and got to get the test back, and got to teach you new stuff. So today's got way too much in it as it is. All right. If you can factor it, you should. But you can't factor this one, so how the heck do you solve it? What do you mean solve, Mr. Server? Well, if I want the x-intercepts, then I set y equal to 0. So then that's a 0. Well, how do you solve that? What are the solutions? They're also known as the roots or the zeros. They're what make the equation equal 0. It's the quadratic what? Formula. X equals -b, except in this case negative what? 3. Plus or minus square root. Everybody finish this thing off. Act like it's the ACT, and they just asked you to solve or find the solutions. If you're coming up with something that has a square root of 19 involved, you're on the right track. Check with the kid next to you and see if you don't have a square root of 19, maybe you could ask him, how the heck do you supposed to get 19? And some of you are probably like, didn't you mean the square root of -19? Nope. Because, yes, there's a square root of -19 in it. I know this is in a terrible color to read, but that can be simplified. The square root of -19, you go -3 plus and minus I root 19 all over 2. Yay. That's what's called a complex number. Oh, 19, not 17, thank you. That's a complex number. Why is it complex? Complex numbers have a real part and an imaginary part. I'm going to break this up further. -3 over 2 plus and minus I root 19 over 2. That makes real, and that is your imag. There's a real part and an imaginary part in a complex number. It's the mullet of math forms. Business up front, it's all real up front. Party in the back, they even have imaginary things. Okay, so what's next? This would be done. You wouldn't have to do anything to this one. You know why? Because it doesn't have anything weird in the denominators. Do you sometimes have weird things in the denominators? Oh, yes, you do. Like, for example, let's say I had 1 plus the square root of 2 all over I. You have to think about what you could multiply by to get rid of the I. And in this case, it's not that hard. That's a good guess. But that would divide everything by I, and that would make it really complicated. Does it really? Yeah, say it. Multiply by I on the top and the bottom. Why is that any better? Because what's I times I? I squared. Why do you care? I squared equals 1. I squared equals -1 to be exact. Now it's better. Why is it any better? Because it's got a -1 on the bottom instead of having a square root. If I had to finish this off, I would say that's 1i, and that's square root of 2i. So that's 1 plus the square root of 2i over -1, and the -1 would just turn into a negative on the top. Dividing by -1 or multiplying by -1 do the same thing. All right, let's do one more that's, again, more like a typical question. I might say I have 2 plus I. That's a weird plus. I'm going to try that again. 2 plus I. And then that's going to be called A. Then I have B here, and it's 3 minus I. The things you're supposed to do today is multiply things together, add things together, subtract things, and divide things. Do you get if I add them together, I just take 2 plus I, and then I add 3 minus I? I'm putting parentheses around it just to make sure I don't forget if there was a negative to distribute. And then the 3 and the 2 would make 5. And the I and the negative I cancel each other out, so it's just 5. Cool, that's pretty easy. Which one do you think is complicated? Divide. Why? So what if I had B divided by A? Then that's 3 minus I divided by 2 plus I. What's the problem? Oh, how do I fix the denominator on this one? Hint, you can't just multiply by I. You got to use something called we had a unit where we use this. It's called a conjugate. Yes, that's called a conjugate. So we're going to multiply by the conjugate. What the heck's the conjugate again? It's 2 minus I. The other one was 2 plus I. This is 2 minus I. I'm just doing that so that I'm going to end up with an I squared. The I squared turns into a -1, and then I don't have an I on the bottom anymore. All right, so take a moment, multiply out the top. 3 times the 2, 6. 3 times the -I, -3I. -I times the 2, -2I, and -I times -I plus I squared. All over on the bottom. You multiply it out. That's typical work for today. It's really just about remembering how to add, subtract, multiply, and divide with these 2 caveats. You can never leave I squared in your answer because that simplifies to what? -1. And you could never leave an answer that has an I on the bottom. Because if it has an I or a square root on the bottom, then you aren't simplified enough. 2 times 2 is 4. 2 times -I, -2I. Positive 2I. Ooh, that worked out nice. Do you think that was a coincidence? No. That's what conjugates do. This last one's I times -I makes -I squared. Conjugates always end up with this awesome those two cancel thing. Because otherwise you'll still have an I in the answer. But if you really use a conjugate, then this part cancels. And then this part's -1. And if I'm minusing a -1, that really means I'm adding 1. So then the bottom is 5. And the top is 6 minus... Wait a minute though. That's going to be -1. Put it with the 6 makes 5. So 5 minus 5i. It's one of those rare times where if you can factor it, you should. Wouldn't be a good idea. Because I want to now take it and instead break it up into its 2 parts. 5 over 5 minus 5i over 5. And now I can simplify it and say 1 minus I. Whoa. All that is what that times that, no, sorry, that divided by that works out to. Okay? You've learned almost everything. Let's flip through some of the slides here. This is the other part. What if you have I? Well, that's square root of negative 1. Should know that one. Definition. How about I squared? We just said it about 500 times. What is it? Negative 1. Then how about the other ones? I to the third. Would you agree that I to the third has got an I squared and an I? You had one too many negatives in there. All right, so this one is negative 1. This one's I squared. I really strongly encourage you to write both. Sorry, times I to the 1, because that makes a total of I to the third, right? And what is I squared? It's negative 1 times, that's a times sign, I. What's negative 1 times I? Negative I. That's it. Negative I. How about I to the 12th? Hint, if it's even, then it's a whole bunch of I squareds. How many I squareds? 6 of them. So that's negative 1 to the 6th. You all should be able to do that. How about I to the 25th? That's an I squared, but it won't work perfectly because I can get it to be the 24th. That'd be I squared to the 12th. But there's a leftover I, so I put times I. That's negative 1 to the 12th. An even number, it's going to make them all cancel. So that's just I. All right, to see if you're really understanding this, would you please compare these two? I to the 9th versus I to the 10th. First, you start by saying it's a bunch of I squareds, and then when you run out of I squareds, then just use regular I's. And then simplify it down from there, because I squared, you know, is negative 1, right? Regular I is just I. Don't change I into square root of negative 1. We can leave our answers with an I in it. The I's will have it. I'm going to pause for a second while you try to figure out I to the 9th and I to the 10th. And I'm not going to try to teach you this until tomorrow.